Hi and welcome to E-ZTutoring. Today we are going to cover equations and inequalities that deal with logarithms. Now, these tend to look very intimidating, and when you see them you usually kind of get confused and scared on how to approach them. But hopefully I can make that a little bit less scary in this video. Suppose we have log base 3 of 2x minus 1 is less than or equal to 2. Well, if you guys do remember, in my previous video I went over how to convert logarithmic form into exponential form. And the way to do that is very easy. You just put a big arrow on the top connecting the 3 to the 2. I'm sorry, big arrow on the bottom and a small arrow on the top. So now this reads 3 to the power of 2 equals 2x minus 1. Now I didn't put the equal sign because this is not an equal sign. We're dealing with inequalities here. So what sign do we put here? Well, you always want to follow this form, right? So you have 3 squared, put that first, and whenever you do this and you convert an inequality with a logarithm, you always have to flip this sign. So this is very important. Instead of less than or equal to, now this becomes greater than or equal to. And of course, if it was less than, it would have switched to greater than. So now this is a very simple inequality that we learned how to solve in pre-algebra. So 3 squared is simply 9. 2x minus 1. We can move the 1 over. So we get 10 is greater than or equal to 2x. Then we simply divide by 2 on each side. And we get that x is less than or equal to 5. So this will be your answer. And you can actually plug this into the logarithm and see how it works. Because when you plug in 5, this becomes 9, and you get 3 squared equals 9. It works. Now, of course, you can't have anything bigger than 5 because this number can be a maximum of 2. See, it's less than or equal to 2. So when you have a number bigger than 5, this will become 10, 15, 20, and to get to that, you would need a number bigger than 2. Anyways, that's not too important. That's just me being a math nerd. Anyways, next example, we have log base 5 of 3x minus 1 equals log base 5 of 2x squared. Okay, so once again, this may look intimidating. And when you see this on a test, you may think, I don't know how to add logarithms, how to multiply logarithms, or how to combine them in any way. And when you think that, you might, overthink it and not really know how to approach this. So anyways, this is much, much easier than it seems. Check it out. These logarithms have the same exact base. 1 log on each side with the same exact base. So what does that tell you? If everything else is the same, then therefore, whatever's inside the logarithms must also be the same. If, say, this log were equal to this log plus 1 or something, then no, you couldn't do this. But since everything is the exact same, the base is the logs, you can set the inside of the logs equal to each other. So now we simply have 3x minus 1 equals 2x squared. So now this is a simple quadratic. And we know how to solve quadratics because we are in Algebra 2, right? So of course, to solve a quadratic, you move everything over to one side. So we subtract 3x and we add 1. Subtract 3x, add 1. We get 2x squared minus 3x plus 1 equals 0. once it's equal to 0, you have to start factoring. Now, when you factor and your coefficient is greater than 2, of course you have to use some special type of method here. I'm not going to dive into this right now because that will take a while, but we'll just go ahead and factor this. We get x minus 1. If we double check, we get minus 3x plus 1. This works. Okay. So something times something is equal to 0. Therefore, this something must be equal to 0. And this something must be equal to 0. Or maybe just one of them are equal to 0. That's why you will have to check your answers. So we add 1, 2x equals 1, x equals 1/2, add 1, x equals 1. There are your two answers. Now, like I said, it would be a very good idea to check these answers. So you plug in 1/2 here, and you get 1/2. Plug in 1/2 here, and you also get 1/2. Plug in 1 here, you get 2. Plug in 1 here, you get 2. So it all works. Okay, one last example here. I should erase the board. Be right back. All right, so last example. Suppose we have log base 2 of 3x minus 5 is greater than log base 2 of x plus 7. So once again, it is very important not to overthink a problem like this. And there are some things you should notice from this. You should notice it is simply a log on each side. And you should also notice that they each have the same exact base on each side. So therefore, what you can do is what we did on the last problem. You can actually set what's inside the logarithm greater than what's inside the other logarithm. It works just like the other one where we set them equal to each other. So now we simply say that 3x minus 5 is greater than x plus 7. So you guys know how logarithms work. 2 to a power would equal this power. So that power would get bigger as this number gets bigger. Once again, I'm just kind of explaining how this step works. Once again, just being a math nerd, or you can just take my word for it and do this. So we want to combine all the x's on one side. So we subtract x here, subtract x here. We get 2x minus 5 is greater than 7. Now we want to combine all the numbers on one side. So we add 5 here, add 5 here, and we get 2x is greater than 12. And of course, to solve for x, we divide by 2 on each side and get that x is greater than 6. So you can take your 6, plug it in here if you'd like, and see if it works. I'm sorry, you wouldn't take 6, you would take something greater than 6. But either way, this is how you work with logarithms. I gave you guys 3 good examples. That should give you a pretty good idea on how to approach these equations and inequalities now. For additional ACT or SAT help, be sure to visit www.e-ztutoring.com. Thank you guys and good luck.